it can be explained by the different theory. First is according to uh, first is Levis theory that can explain the octet rule. Second theory is VSCPR. After that, next theory comes is VBT. Then there are some limitations that cannot explain the pi bonding as well as the lone pair of electron and how much the structure when molecule get dimerized. Then next theory comes is MOT, molecular orbital theory for a covalent molecule. We can say covalent bonding. Next theory comes for an coordination compound. Coordination compound means there is a in case of a covalent bond, the equal sharing of an electron. But in case of a coordination bond, the contribution of a one atom is higher as compared to another atom. The sharing of electron, but the participation of a one atom or element has a higher contribution as compared to another atom or element. That's why we will start with a coordination compound. This is visible to you. Yes. Coordination means the coordinate bond, there are a different type of bonding. First is ionic bonding. In case of a NaCl, or we can say any, in case of a NaCl or any compound which has positive and negative charge, that is ionic bond. Second bond is covalent bond. Covalent, in case of a covalent, the sharing of an electron, the sharing of an lone, or we can say sharing of lone pair of electron, the equal contribution of sharing. But in case of a coordination, the participation of a one atom or element higher as compared to another. We can say in case of a metal to ligand, there are a coordination bond this way. The contribution of a ligand is towards metal, that is only one way. But in case of normal, we can say covalent bond, the metal to ligand, that bond is known as covalent bond. But the contribution of one element or one atom has higher as compared to another, that is coordination bond. The main difference between the coordination and the covalent bond. Second is ionic bond. In case of a ionic bond, the contribution is like a Na plus Cl minus. That bond is ionic bond in which ion is contribute in bonding. That is the main difference. That's why first, then we will start with a coordination compound. What is coordination compound? Coordination compound are the compound in which coordination bond is found between the metal to ligand. Ligand, what is metal? Metal means the metal which has tendency to accept the lone pair of electron from ligand, that can stabilize the bond. Ligand, the donating site, or we can say donating atom, that can donate its lone pair of electron to metal atom, that can stabilize the bond, that is ligand. That's why there are a different type of a theory that can explain the coordination compound. In case of a coordination compound, there are a different type of a theory that can explain the coordination compound. First theory is Blemester theory. In this theory, second is Warner theory, second is Chiswick theory, next is poly-electroneutrality principle, next is VBT, and then CFT, and then final comes in MOT. there are a different type. In case of a covalent compound, there are different theory. First is Lewis theory, second is VSCPR, third is VBT, and fourth is MOT. But in case of a coordination compound, there are different type of a theory. The trends going on this way. First, that is Blemastad theory. In case of a Blemastad, the scientist name is C.W. Blemastad in 1826 to 1894. That can give, that can give the theory in form of a nitrogen form, like a structure. In case of a nitrogen, if we say the nitrogen is a contributing part, that can give the contribution to metal atom, that is, or we can say that chlorine ion that can dissociate directly attached to that negative part and directly attached to ammonia molecule. That's why it does not explain how it is happened. In case of this, if we count, this is the unable for dissociation because it is not attached with ammonia. Ammonia is a Lewis base which can easily donate its lone pair of electron to metal atom. Based on this theory, it does not explain the exact coordination. That's why next theory come roll into play, that is the Warner theory in 1893. In 1893, that can got a Nobel Prize in 1913. That can explain the coordination compound. According to this theory, every coordination compound that exists two type of vacancy. First vacancy, that is corresponding to primary vacancy. Primary vacancy means that has an oxidation number. We can say if I write cobalt, sorry, if I write cobalt, ammonia 6, and this is Cl3. This is Cl3. This as cobalt is the central metal atom. Cobalt has a tendency that can give the oxidation number of a +3. That is the cobalt charge. And according to this secondary valency, that is the ligand that is attached with that metal atom. According to this, it has a secondary valency is, valency is 6 and primary valency is +3. That's why it is in ionizable form. Primary vacancy means it is an ionizable form, that is non-directional, means that does not change, means that can corresponding to oxidation state of an complex. But according to secondary valency, it is non-ionizable vacancy that can exist either Cl is inside the we can say coordination complex or outside the coordination complex. There are a two probability. That's why it is an we can say that is in directional and which has some stereochemistry of an complex. That's why every complex, metal ligand complex, or we can say coordination complex, that exists in two type of a valency. First valency that corresponding to oxidation state of an complex, and that is ionizable valency, that can corresponding to oxidation state, which is non-directional. But according to secondary valency, that is non-ionizable vacancy, that can corresponding to coordination number of the complex, coordination number, whether it is a hexa, or we can say octahedral, tetrahedral, or triangle, bipyramidal, this way. And that is directional, and which exist in form of a stereochemistry. According to this theory, there are different, the every complex that exists in the form of colored compound means which show impart color with light. Light means if it is adsorbed some type of an complex that is exist in two way, either it is formed in double salt or in coordination complex. If I say I add sorry cobalt cobalt chloride, we can say it is exist in and 6 hydrated, that is the normal salt that exists in double salt, we can say double salt, this is double salt. But if it is goes in double salt, but if it is exist in coordination sphere means that sphere which has metal and ligand, and some outer ligand is also attached like HClN, like this way. This is coordination sphere, and this is double salt. What is the main difference between the double salt and coordination complex? In case of a double salt, if we dissociate, or we can say if you add any solution, like if we add ammonia, that can easily dissociate into a ammoniated cobalt ammoniated chloride, this way, plus HCl. But in this coordination complex, if you add any solution, like if you add ammonia, that does not easily dissociate. Oh, the double salt as well as coordination complex both are coordination compound. But the main difference in coordination compound and double salt, the double salt that is easily dissociated in solution to give different complex. But in case of a coordination complex, if you add some solvent or any solution, that cannot easily dissociate. That's why it show a different type of a color. In case of if we take an example of cobalt chlorated 6 ammonia, this is double salt, that show a yellow color, because in because the if you add some water or any light is absorbed, then it show a different color. But in case of a 5, if it is 5, then it shows some purple type of a color. But the ligand attached is, we can say, 4. In case of a 6, 5, 4, then it is a violet. And after that, it if ligand is decrease means the color intensity is increase, that is inversely proportional. That's why it depend upon the coordination number. In this case, the coordination number is different, this case coordination number is different, this case also coordination number, this, that's why two type of a valencies arise. First is primary valency, second is secondary valency. And according to this theory, these valency explain whether the complex show a different color or not. This is the main assumption according to Warner theory. And this Warner theory then come into play with a different spectra. Different spectra means that can show a different color. Color means that has some intensity or some color. The metal has to satisfy both the primary as well as secondary valency. That's why it has some negative. Primary valency are satisfied by a negative ion, and thereby secondary valency are satisfied by either ion or a neutral molecule. In a certain case, it is maybe negative ion or a neutral. That's why both type of a valency can exist in coordination complex. In case of a secondary valency, they are always directed towards a fixed position in a space that exists in stereochemistry, which has some stereo center that has not that has some superimposable mirror image. If we say like a this complex, like a cobalt chloride 6 ammonia, 6 ammonia means that has an coordination number that has an primary valency is exist due to plus 3 charge, means cobalt is central, x minus 3 is equal to 0. X is the 3. X means that is the oxidation number on cobalt, that is in plus 3. But these are the 6 ammonia that is attached. That's why it is in hex, or we can say octahedral. Octahedral means that has in some shape. 4 ammonia here, 2 ammonia here, 2 chloride, that is 3 chloride that is attached here, here and here. These are the primary valency which corresponding to chlorine, which can easily dissociate. Easily dissociate means if you add some solution that can easily dissociate to give different metal salt. We can say if we add some another salt like a silver, Ag, that can easily dissociate to give AgCl plus cobalt, 3 AgCl plus some cobalt complex, CO ammonia 6. Ammonia 6. This is the way. This is the way that can attach with, or we can say if you add nitrate, then cobalt ammoniated nitrate and 3 in the form of 3. 3 L is formed and ammoniated. That ammonia is coming here, silver comes here. This is the main example whether these complex show a different color. In case of a silver, it is easily react with silver, either in silver chloride, silver bromide, or silver nitrate. Silver nitrate. If this complex show an yellow color, yellow color, sorry, white color. This is white color. This is white color. This is yellow color. And this is blue color. That's why these chloride that is attached, means 3 that is corresponding to oxidation number. Oxidation, that is ionizable, means every solvent that has tendency to react itself to give different metal salt, that can different type of a ppt with a molecule which has like a AgCl, AgBr, Ag nitrate, this way. That's why number of ionizable ion that can give the complex, how much complex these are formed, and number of cation present is, in this case we can say, is 1. That's why total number of ion in form of a plus 4, and these are the ionizable vacancy, we can say primary valency that can arise a charge means that has some conductivity means if it has a conductive that has some charge is arise due to two way, either it is in form of ion or in form of electron. Conductivity due to ion means if it is dissociated into a solution, then it arise some conductivity means that can conduct the electricity, or means it is in form of either positive or neutral or negative. Next is, this is very important question arise when when a complex that can dissolve in excess of Ag nitrate, silver nitrate, that show an white color of a spectra, means that form an AgCl, and the nitrate that is exist in form of an AgCl, Ag nitrate, that is easily dissociate and react with that complex, and the chloride ion that is in form of a primary ionizable thing that can easily react with that Ag plus to give the ppt of an AgCl. That's why these are the type of an primary vacancy that can give the ppt. How much ionizable means there are three, means 3 AgCl is formed. If we take an example of a 2, if we 2 means there are, if the ionizable thing are 2 means cobalt 3 ammoniated and 5 nitrated, means that as exist in form of an 2 chloride ion, these are the chloride primary, and means that exist in 2 AgCl ppt. 2 AgCl ppt means all the ammoniated ion that exist in form of one complex, but these chloride, 2 chloride, here 2 chloride means that exist in form of one 2 AgCl ppt either, or 3 ppt. It depend upon how much ionizable ion that is attached with any metal atom. Here in this case 1, 2 and 3, but the ammoniated ion is 5. Ammoniated ion 1, 2, 3, 4 and 5. That's why it satisfy the primary as well as secondary valency. If primary valency is satisfied, then we can come to secondary valency. Secondary valency means secondary valency the molecule is stable, but the main problem in this one, after satisfy the secondary valency, it goes to primary valency. Primary valency, that is ionizable thing. In this case, after it form an octahedral means total ligand attached one, that in ammonia remain in ionization form, that from 2 AgCl pp to 3. But if it attach with 6 hydrated means satisfied. That's why T chloride that can corresponding to 3 AgCl. But if 5 related ion is attached, means one that can satisfy from chlorine ion. Chlorine ion easily donated its valency that can give 2 AgCl. If we take an example, another cobalt chlorated 4 nitrated means they here are the cobalt 4 ammoniated. One is from here, one is from here, one is here, and one is from here, and two chlor 3 chloride. 3 chloride means one here, one here. After that, its octahedral structure is completely satisfied. Means coordination number is 6, or we can say 6. After that, one chlorine remain. This chlorine can easily associated with silver nitrate in form of an AgCl that can easily dissociate it. That's why this theory explain whether complex exists in form of a two type of a valency. One is from valency that corresponding to oxidation number of a complex. Second valency is corresponding to coordination number of complex. And primary valence is ionizable thing and directional in nature. We whether these are interconverted into another form. But in case of an secondary valency that corresponding to coordination number of an complex, which is satisfy complex, means that is not ionizable. Not ionizable means that has some directional in nature, sorry, non-directional in nature. In every complex satisfy both the valency means first form is coordination is satisfy. After that, oxidation state, whether this exists in +2 oxidation state or +3 oxidation state. That's why it can easily react with another atom, to give the stable complex. Complex, there are two type of chances. One is from it react with another metal salt, or it is easily dissociated with the complex. And these the dissociated ion that can increase the conductivity of a solution, because these are the ionizable thing that can easily give the ion that corresponding to conductivity conductor, or we can say semiconductor type of exam. We can say if there type of question arise. One is from the conductivity, how much conductivity of a that complex. If there are a more ionizable ion, that can increase the conductivity more. If there are less number of ion in form of ionizable, that can give less conductivity of an complex. And that complex show a different color, whether it is in form of a chloride, bromide, or nitrate. In case of a chloride, it is a white ppt. In case of a bromine, it is a yellow. And in case of an nitrate, it is in blue color, like this way. There are the thing that can consider. If any doubt, please raise your hand. Uh, If any doubt, please raise your hand. Otherwise, write in chat box. We will discuss. Otherwise, we will continue. Next theory come is, or we can say, different type of a metal complex. Here are the some assumption in coordination according to Warner theory, that there are different assumption. There are different assumption means every atom has every coordination complex that in metal to ligand attachment, that there these type of a bonding that exists in coordination complex, that is simple ionic form and some percentage of ionic plus some percentage of covalent. That's why the organic bonding theory are simple and ionic charge coefficient. That's why it exists in two type of valency. One is corresponding to primary valence, second is second valence, that can give the coordination number. Coordination number means that metal that surrounding with how much ligand, that is secondary valency, primary that is exist in how much the oxidation number of the complex, coordination number of an complex. Then how we define the trans and metal complex, whether it is a coordination trans and metal complex. There are a different type of metal that can interact with the different type of a ligand like a CN that can give complex, and this complex is known as double salt. These are the double salt we can say. But after complex contain a metal that is bounding a cation or anion that is in form of a coordination complex, then it is a coordination compound. Otherwise, it is a double salt. The main thing is this one we can say, these are coordination complex in a square bracket, and these are the ligand that can donate it the lone pair or into a metal atom. These are the outer sphere ligand. That's why there are coordination sphere that contain a metal that is bound with ligand, and the number of donating that can give to metal atom or ion complex, whether it form a tetrahedral or square plane of a tetrahedral and square planar, the coordination number or donating is 4, but in case of an octahedral, height or donating metal is around 6. That's why large ligand, those are sufficient to transfer the negative charge to metal that can favor the lower coordination number, and the coordination that can give the secondary valency of an atom, of an complex, or the next charge is the oxidation state. In this case, the coordination, the charge in this case is X. Iron is central metal atom, and the ligand that is donating means X minus 6 is equal to minus 3. Minus 3, that is in form of an plus 3 charge on a complex. Plus 3 charge on complex. Then next term is come. That's why the primary valency in this case is plus 3, and the coordination number, or we can say secondary valency, is an plus 6, we can say 6. And next is neutral. We can say, we can categorize the coordination complex according to its charge. It's a negative charge, or we can say anionic complex. Anionic coordination complex. Here is the negative charge, that's why it is known as anionic coordination complex. Second chances is neutral. Neutral compound means that has an charge is negative, but it is also exist in form of an primary as well as secondary valency. Primary valency in this case, the copper is central metal atom, and ammonia that can give 0 minus 2 is equal to 0, means x is the plus 2, that corresponding primary valency. Valency is 2, or we can say plus 2, but the valency in this case that corresponding to secondary valency, and that secondary valency is around 6. Secondary valency is 6. Next is, we can say neutral charge, but we have already discussed, these are the plus 2 that is corresponding to code, that is oxidation state or often sent. These are the attaching link, that's why it's coded is 6. And these are the ligand, that's why the ligand can be categorized into various category, whether you donating site. One site means it is a monodentate. Monodentate means only one side that donate towards cell. That is one monodentate. Bidentate means that has two donating side. Tetradentate means total four number of side that is donated towards metal. Hexadentate, polydentate, more than two. That's why the ligand that can categorize into various category, either it is dentate, bidentate, tetradentate, hexadentate, or polydentate. Polydentate means it is more than two. And these are the more than two, or we can say it is a bidentate, whether it is in a chelate, it is a form of a two, bidentate, tetradentate, hexadentate. In case of a monodentate ligand, the example of a monodentate ligand are in form of a water, Cn minus. Here the oxygen only one donating side. In this case, the nitrogen donating side. This case, nitrogen only one side. One OH minus 1, SCN, halide, carbonyl, or peroxide. These are only monodentate ligand. In this ligand, it can form an coordination complex, and that is attached with ammonia that can give the coordination compound with monodentate ligand. Next is bidentate. In this case, bidentate is like a C2 4. Here are oxygen, and this is also an oxygen. Negative charge arise here, negative charge arise here. Donated from this side either, or this side, means it give two side donation. Two side donation means it is a bidentate. Oxalate, this is an oxalate, or ethyl diamine. Ethyl diamine means C2 CS2, CS2. Whether it is form one NH2, and here is also NH2. NH2 that has two operating side, one from this side, second is from side. That's why it is a bidentate ligand or orthophenolphthalein, or we can say the complex formed in this case like a cobalt ethylene diamine in tetra form, and plus 3 the sorry charge on a complex. This type of a complex is formed in case of a bidentate ligand. Next is the oxalate. Oxalate has a tendency in this way. There are the structure of an oxalate, ethyl diamine and orthophenol. These are the donating site that can exist in form of an in form of this way, and in this case the donating site here and here. But in case of orthophenolphthalein, this is the donating site. In this case also the donating site is, that's why it is bidentate ligand, or the complex formed during these are the. Or next is hexadentate. Hexadentate means total number of donating site is 6. In this case, the hexadentate means total 6 donating site that is attached with a metal. If we take an example of EDTA, ethyl diamine tetraacetic acid, here are the we can say nitrogen and CH2, and this is the EDTA is the main example that can give the, they give the donating site is 6. Like this is the main that is found in EDTA. In two nitrogen that attached, two nitrogen that is attached, here are the one nitrogen, second nitrogen, two ethyl, ethyl diamine tetraacetic acid. Tetraacetic acid means one is acetic acid, second, third, and fourth of a tetraacetic acid, and diamine, two amine, one amine, two amine, two type of amine, and four tetraacetic acid. That's why it has tendency to donate from this side, and this side, and also this side and this side. Total number of donating site here is 6. That it is hexadentate. Okay. Then we will come to common geometry that exists in a coordination complex. According to this, whether it is formed in two oxidations, which type of a geometry exists in a coordination complex. In next class, we will start with common geometry exists in complex, whether it is in stereo selective or stereo specific or stereo selective, and number of geometry isomer, whether it has geometry isomer 2, 3, 4, this way, whether it is from cis, trans, or E or Z type of an configuration. Any doubt, please raise your hand, otherwise write in chat box. Any doubt in this class, please raise your hand, otherwise write in chat box. If no doubt, then we will start the class tomorrow. Okay, then